Naming alkenes are very similar to naming alkanes, except that alkenes have double bonds that you have to take care of. I was using this chart for naming alkanes. Now, I will be using this chart on the right for naming alkenes. For alkanes, you had ane ending. For alkenes, you will have ene ending. There is no such thing as methane because you need at least 2 carbons for a double bond. Alright, let's get to naming now. This alkene looks like one continuous carbon chain without any substituent. So all we have to do is count the number of carbons for the name. It has 1, 2, 3, 4, 5 carbons. 5 carbons give you pentene. Since this has a double bond, we have to include the location of the double bond. So we have to number the chain in a way that gives the double bond lowest possible number. If we start from the left side, we get 1, 2, and that's where the double bonds start. If we go from right, 1, 2, 3, the double bond starts at 3. Since we want the lowest possible number on the double bond, we'll start counting from the left side. 3, 4, 5. The double bond is located at 2, so we'll just include a 2 before pentene and a dash between them. That's the final name. Just by looking at this alkane, it looks like this is the longest continuous carbon chain, but your double bond must be a part of the main chain. So this is incorrect. You have the option of choosing these to be your main carbon chain or these to be your main carbon chain. Since this is longer than the other one, we'll stick with this one. This has 1, 2, 3, 4, 5 carbons. 5 carbons give you pentene. And it has a ethyl attached to it. Remember, for alkene, double bond is more of a priority than the substituent, so you want to make sure you give the lowest possible number to your double bond. You start counting from here. 1, 2, 3, 4, 5. Your double bond gets the lowest possible number, which is 1. 2 ethyl, 1 pentene is the final name. Ethyl is located at 2 and the double bond starts at 1, so that's where pentene gets 1 from and ethyl gets 2 from. So first we identify the longest continuous carbon chain. This appears to be the longest continuous carbon chain that has double bond in it. It has 1, 2, 3, 4, 5, 6, 7 carbons, which is heptene. It also has a methyl group attached to it. Now we have to number these carbons so that the double bond gets the lowest possible number. Since the double bond is closer to the right, we'll start counting from the right side. 1, 2, 3. 3 is where the double bond starts. 4, 5, 6, 7. So we know methyl is at 4 and double bond starts at 3. So we just have to put this together for the final name. 4-methyl 3 heptene is the final name. The longest continuous carbon chain that has double bond included is this one right here, and it has 1, 2, 3, 4, 5, 6 carbons, which is hexene. It also has a methyl group attached to it. Now we have to number the carbons so that the double bond gets the lowest possible number. If we count from the left, we get 1, 2, 3. Double bond starts at 3. If we count from the right, we get 1, 2, 3. Double bond starts at 3. So when there is a tie between the double bond, our substituent is the next priority. We want to give the lowest possible number to substituent, or the methyl group in this case. So if you count from the left, methyl gets 3. If you count from the right, methyl gets 4. So we want to stick with counting from left side. 4, 5, 6. Now we know the double bond starts at 3, methyl is also at 3, and all we do is just put them together for the final name. 3 methyl, 3 hexene is the final name. Now this alkene looks a little different. It has 2 double bonds instead of 1 double bond that I've been working on. As always, we first count the number of carbons in the chain. So it has 1, 2, 3, 4 carbons, which is butene. It doesn't matter which side we start counting from since they are identical. So we'll just start counting from the left side. 1, 2, 3, 4 carbons. So we have 1 double bond that starts at 1 and 1 double bond that starts at 3. If you remember from alkanes, we use Latin prefixes for multiple of the same substituents. For 2, it's di. 3, it's tri. 4, tetra, and so on. Since we have 2 double bonds in this alkene, we have to include di in the name. 2, 3 dash butadiene. Di before ene just means there are 2 double bonds in the alkene, and you have an A for the pronunciation. So 2,3-butadiene is the final name for this alkene. This alkene has 2 double bonds, and the longest continuous carbon chain is right here. It has 1, 2, 3, 4, 5, 6 carbons, which is hexene. It also has an ethyl group attached to it. Now if you count from the left side, 1, 2, your double bond starts at 2. And if you count from the right side, 1, 2, your double bond starts at 2 as well. So we look at the substituent next. If you continue counting from the left, your substituent gets the number 3. And if you continue from the right, the substituent gets the number 4. We want to give the lowest possible number to the substituent if there is a tie between the double bonds. So start counting from the left side. 3, 4, 5, 6. Now we just put this together for the final name. 3 ethyl 2, 4 hexadiene is the final name. There are 2 double bonds, one started at 2 and one at 4. And since there are 2 of them, we have to include a di in between hex and ene. And that's it for this video.